In the sciences, we deal with measurements which are represented by a number with a unit describing what is being measured. An example is 34.5. As we learned before, the number is meaningless without the unit. In this case, 34.5 grams. Many times, though, the measurement that is taken is not in the units that we want, or the measurement is one of several that is a starting point to derive another unit. A few examples of converting units are dollars to euros, inches to centimeters, milligrams to kilograms, cubic inches to liters, pounds per gallon to grams per milliliter, and feet per second to kilometers per year. In each of the above examples, the same basic principles for converting the units are used. Dimensional analysis is the one-trick pony of which we do many variations. So let's begin. First, a word of caution. Many of you will have learned how to do some simple conversions in math class by using a simple proportionality. While mathematically the principle on which dimensional analysis is based is a proportionality, we are not going to take some of the shortcuts you may have used, since we will use dimensional analysis as a problem-solving tool for more difficult conversions which are more common. In short, don't take shortcuts until you have mastered the process, and then your shortcuts still need to follow the format. The fundamental idea behind dimensional analysis is that you cancel units that you do not want and keep the units that you do want. In fact, this is how you know a conversion is complete. You only have units you want left, and all other units have been canceled. We will treat the units in a measurement just as you would a variable in algebra. So if you had 8x times 3y over 4x, you would go through and cancel out the x's to simplify and continue to solve the equation on out to get 6y. The units that we use in dimensional analysis we will treat just as we did these variables. So as we will see, we'll set up conversions similar to this, where in this case our inches, the units for our measurements, are our variables in our conversion. We would do the same thing as we did above, cancel those units, and then go ahead and solve the problem with the remaining unit, our remaining variable, being yards. As seen above, being able to do conversions requires knowing certain proportionalities that relate to the units you are converting. These are called conversion factors. Some examples are shown here. Some conversions you will memorize, such as the metric conversions between the base unit and the units centi, milli, micro, and kilo. Others you will look up like the ones above. Some you will learn how to make on the fly based on what you are working with. More on that later in the course. Now, let's do a simple conversion to introduce the basics. We are going to convert 4,750 inches to miles. We always start with the known value, or what I call the given. Write 4,570 inches over 1. Always include the unit on all numbers. They are our variables and we need them to cancel. The 1 is the placeholder and you can leave it out if you wish. I will in future examples. Now, there are different variations on how to show the conversions, but all are equivalent and follow the same rules. Place a times blank next to the 4,570 inches. Since we do not want the unit of inches, we will place the unit, inches, in the denominator of the times blank. This way, they will cancel since the same unit or variable is in the numerator and in the denominator. Make note, the times blank and putting the unit to cancel are automatic in this process. You must at least do this to help the process along. Now we look for a conversion factor that we know that we can convert from inches to a unit that will help get to miles, since we do not have a conversion from inches to miles. If we look back at the list of conversions we had before, we see that we have a conversion from inches to feet. So put feet on the top of the times blank. Fill in the numbers for the conversion, 12 in the denominator and 1 in the numerator. Confirm that the unit of inches will cancel, and now we have the unit of feet left. Feet is not a unit we want. We need to do another conversion. Start this by placing another times blank next to the feet divided by inches conversion. Since we do not want feet, place it in the denominator. Find a conversion factor that will help get to the unit of miles. Looking back at the list of conversions, we find a conversion from feet to miles. 5,280 feet equals 1 mile. Place the unit mile in the numerator and fill in the numbers. 5,280 feet in the denominator and 1 in the numerator, and confirm that the units will cancel out. The only unit left is a unit of miles, which is what we want. Put an equal sign at the end of the problem and solve for the answer, 0.0721 miles. Now I want to re-emphasize, you need to show all of your work, including the units. Take each conversion step by step and confirm that you are canceling out the units correctly. Doing these things will make problem solving much easier in the long run and just about guarantee a correct answer each time. Now let's do another. This time, a word type problem. The post office charges for delivering the mail by weight measured in ounces. I have a balance at home that measures the mass in grams. If I measure out an envelope with some documents and having a mass of 157 grams, what weight do I report to the post office in the unit of ounces? Okay, pretty simple. Our known value or given is 157 grams. We need to convert it to ounces. So the question can be summarized as 157 grams equals how many ounces? So we begin by writing out 157 grams times blank with the unit of grams in the denominator. We find that we can convert to pounds, so we place pound on top and fill in the numbers, confirming that the unit of gram will cancel. We set up another step with the units of pounds in the denominator, since we do not want that unit, and find a conversion to ounces and place that on top. Fill in the numbers and confirm that the pounds will cancel out, and solve the problem with the answer being 5.54 ounces. This should give you a decent start to making conversions. Keep in mind that some conversions may only take one step, but others may take up to 5 or even more depending on the units being converted. No matter what, follow the process and the problem will be easy to solve.